Here we're going to take a look at adding and subtracting polynomials. So I've got a few problems to work through here. I think it's the best way to kind of learn how to do this. Looking at this first problem, we're asked to add these two polynomials together. And if we're going to add polynomials together, we need to keep in mind that we can only combine like terms, meaning we can only add terms that have the same base variable as well as the same degree or exponent. We can only add those together. For instance, 3x cubed could only be combined with another x cubed term. So looking over here, I see that we have a 2x cubed. Those would be considered like terms, so we could add those together. In fact, I'm going to mark those. 3x cubed from this polynomial is a like term with 2x cubed. So if we're adding these polynomials together, those two terms could be combined. And I'll write that down here. I just realized I wrote this polynomial over here a little bit incorrect. Let me see here. I think that's supposed to be a squared. Okay, so looking at this second term in the first polynomial, this minus 6x squared, do we have any like terms in the other polynomial that we're adding? And yes, we do. This middle term here is an x squared term, so those could be combined. Finally, we've got an positive 8x in our first polynomial. Do we have any regular x terms in our second polynomial? Yes, we do. We've got a minus 13x there. So those are like terms. We can combine those. Okay. Finishing this up, if we combine the 3x cubed with the 2x cubed, that's like saying 3 apples plus 2 apples. We're still going to have apples or x cubes in the end. We're just going to have more of them. 3 plus 2 is 5. Let me change my colors here. This would be 5x cubed. Negative 6x squared plus 9. Negative 6 plus 9. I know that's 3, but we'll check it here in the calculator. Negative 6 plus 9 is 3, so that'll be a positive 3x squared. And then 8x minus 13x, 8 apples minus 13 apples. Is negative 5. So our final answer here would be 5x cubed plus 3x squared minus 5x. Let me try to give myself a little more room here. Okay, now we can take a look at the second problem. Here we're asked to subtract. So the only thing to keep in mind when you're subtracting polynomials is we're asked to subtract this entire polynomial over here, which means we can almost think of this as being a negative 1 on the outside of parentheses. So we need to distribute or multiply this negative 1 by each term in the parentheses before we can move on. So let's do that now. Negative 1 times 5y squared, that would be a negative 5y squared. Negative 1 times negative 2y. Well, negative times a negative is a positive. That would be a positive 2y. And a negative 1 times a positive 9 would be a negative 9. And I'll bring down the terms from our first polynomial. Now this is pretty much like our first problem. We can combine like terms. So let's see here. I see a 2y squared. Are there any other y squared terms in the problem? Yes, there's one right here. Minus 5y squared. So those can be combined. 2y squared minus 5y squared. I have a minus 2y term here. Are there any y terms in the problem? Yep, there's one right here. So that's a minus 2y plus 2y. And finally, I've got a regular old 7 here. Are there any other regular numbers in the problem? And the answer to that is yes. We have a minus 9 there, so those can be combined. And then if we work those out, what do we get here? We have 2 minus 5, or 2 apples minus 5 apples. That's negative 3 apples, or in this case, we're talking about y squared. Here we have negative 2y plus 2y. Negative 2 plus 2 is 0. That would be 0y, which means those basically cancel out. We don't need to write down a 0. 7 minus 9, that's negative 2. I'll move this over since we have a little more room. So our final answer here would be negative 3y squared minus 2. And again, this minus 2 came from this 7 minus 9. Alrighty, one more problem to look at here. We're asked to find the difference. So we're asked to subtract these two polynomials, but there's a little twist in this problem. We've got a number sitting on the outside of the parentheses here and here. And again, anytime we have something outside the parentheses like that, we need to distribute, meaning we need to multiply by each term in the parentheses. So that'll be our first step here. We're going to take 9 and we're going to multiply it by 4y squared. 9 times 4, that's 36. And we still have our y squared. 9 times negative 7y, that's negative 63y. And 9 times 9 is 81, so plus 81. That takes care of that. Let's move to this one here. We've got a negative 2 times 5y squared. Negative 2 times 5, that's a negative 10. Negative 2 times a negative 9y. Negative times a negative is a positive. And 2 times 9 is 18. Whoa, what is happening there? 18y, again from taking negative 2 times negative 9y. And negative 2 times 7 is negative 14. Now we just go through like we did in previous problems and we look for like terms. I see a y squared term here, 36y squared. And here's another y squared term here. So those are like terms. Okay. Negative 63y here. Do I have any other y terms? Yep. There's an 18y. And an 81, are there any other regular old numbers with no variables attached to them? And there are, right here. Negative 14, so we'll have a plus 81 minus 14. Combining those, we have 36 apples minus 10 apples. I don't know why I keep saying apples, I think I'm hungry. 36y squared minus 10y squared, that would be 26. 36 minus 10. And negative 63 plus 18. I have no idea what that is. Negative 63 plus 18 is negative 45. Don't forget our y. And 81 minus 14, 67. So plus 67. We've distributed the number on the outside of parentheses. We combined like terms, and we've come up with our final answer here of 26y squared minus 45y plus 67. So just a short video on how to add and subtract polynomials. Hopefully that was helpful.